In this investigation, we learned that when two quantities change together so that one's measure is always the same number of times as large as the other's measure, we say that they are proportional. For example, in the crank and bucket context, the bucket's height above the water in feet, h, was always 2.5 times as large as the number of rotations the crank was turned, n. So, the bucket's height above the water and the number of rotations the crank was turned are proportional. If we find any value for the bucket's height and the corresponding number of rotations for the crank, the ratio will always have a value of 2.5. For example, when the crank has rotated 3 times, the bucket is 7.5 feet above the water. In this moment, the ratio of the bucket's height above the water in feet and the number of rotations of the crank is 7.5 divided by 3, which is equal to 2.5. This also means that in this moment, the bucket's height above the water in feet is 2.5 times as large as the number of rotations the crank was turned. When the crank has been rotated 4.5 times, the bucket is 11.25 feet above the water. In this moment, the ratio of the bucket's height above the water in feet and the number of rotations of the crank is 11.25 divided by 4.5, which is equal to 2.5. This also means that in this moment, the bucket's height above the water in feet is 2.5 times as large as the number of rotations the crank was turned. Since the bucket's height above the water in feet is proportional to the number of rotations the crank was turned, the ratio of the bucket's height above the water in feet to the number of rotations of the crank will always be 2.5. And hence the bucket's height above the water in feet will always be 2.5 times as large as the number of rotations of the crank. This is constantly true as the number of rotations of the crank and the bucket's height above the water vary together. Of course, we can also say that the number of rotations of the crank is proportional to the bucket's height above the water in feet, and the number of rotations of the crank is 0.4 times as large as the bucket's height above the water in feet, because the ratio of the number of rotations of the crank to the bucket's height above the water in feet has a constant value of 0.4. This is constantly true as the number of rotations of the crank and the bucket's height above the water vary together. One final comment. We need to be careful not to assume that there is a proportional relationship between every pair of quantities we come across. For example, recall the example where a rope was unwound from a spool. The length of the rope pulled out in feet was always 1.25 times as large as the weight of the rope in ounces, so the length of the rope and the weight of the rope were proportional. But, when we placed a hook at the end of the rope, the combined weight of the rope and the hook was not proportional to the length of rope pulled out. The values of these quantities did not have a constant ratio.